Alright, welcome to the lunchtime video happening regularly as planned today. Looks like my mic's a little bit hot. Bring that down. There we go. In the high green, occasionally in the yellow. Let's keep working on the last topic, OPS, but unfortunately the reason I'm having trouble making progress on that is because I'm having more issues with Triton Mode that I used to have issues with before. I worked to resolve those issues, and I learned that you need a license and you need to set the chassis network services mode to the proper setting. I did all that, and it didn't get anywhere. So what I did in the last video, and where we stopped, is I created a new machine. So I'll point that out once I open GNS here. Okay, so here's the machine that I created that's brand new. So let's try making a basic L3 VPN on here and see if I get those same Triton mode issues. Okay, so we've got everything configured except for the key. Unfortunately, I can't show that, so I'll do it on my second screen. I'm probably accidentally sharing my second screen. I've done that before. Oops, no, actually I'm using a new kind of software, so I don't have to choose which screen to share every time now. It automatically shares the screen I wanted to share, and not only that, I can actually look at the software and see what is being recorded and shared at any time. Oops. Invalid license data. That's no good. Incorrect checksum, invalid license data. Well, that's no good. Huh. Okay. Never seen this before. I wonder if my license just expired. Oh, okay. I was adding it wrong. Okay, so that's good. Okay, so now I've got this set up. So let's try a more basic configuration on here to test if it's been successfully taken out of Triton mode. Okay, so we're going to try to configure this routing instance and add a physical interface to it and see if we get that Triton mode error. Okay, so they don't have the route distinguisher or anything like that in here. We'll just have to make up our own. Let's do that. Let's see what happens if I try it without the route distinguisher. I'm pretty sure it'll just say I need the route distinguisher though. Yep. Okay, so yeah, this is successfully outside of Triton mode. You can see if I try the exact same configuration on the other routers, it's gonna not accept it because it's gonna say that it needed Triton mode. So let's do that. Let's strip down one of these routers completely and just add this exact same configuration, and we'll see that it's because of Triton mode. So I'll detach this and move it over here. And you can see everything else is exactly the same. If I do a show system license, we've got the same licensing. Yep, the VMX Juniper eval is the same. Everything's exactly the same. License identifier is exactly the same. Software serial number is exactly the same. So everything is fine there. Let's do a show configuration chassis pipe display set relative. Yep, we've got see everything's in the same mode already as far as that's concerned. But let's do a configure private and then a show pipe display set, and same thing here, but instead of the show pipe display set, we'll delete everything that's here, and then we'll just add everything here, and we'll get that Triton error. So we can see clearly there is some behind the scenes, bug that is yep. So yep, perfect. So we can see that there's some kind of behind the scenes bug happening with these devices, where they've been up and they've been live for so long that there's just something happening on them that's breaking down. But the good news is the solution to that seems to be just to make brand new devices. So even more good news, I don't need a VPN to do FRR. So I think what I'm going to do in this video is just completely finish up FRR. We're going to build a LSP that switches over using FRR, and then we'll mark this off as completely done at the end of this video and move on to the next topic later. It'd be great if I could come back and finish this eventually, because this does look like a pretty interesting documentation, but it unfortunately is just gonna be too much time to go back and reset all the routers right now. So, up to 55. Thanks everybody. So, yeah, I'm going to check if my other one, and I apologize. Usually I think a bit more on it. I'm not sure. I'm not sure if I seem a little bit less focused or something, but in a way I kind of feel that way. I think it's just yeah. Okay. Oh, okay. But I did upload that, so that's good. I mean, I don't think I'm too far off track. Like, you know, I've still been. I missed my video yesterday and stuff like that. But it's just hard to consistently study every day for something like this. And I think I'm just kind of being a little bit too hard on myself, especially since I am making the video right now during my regular lunchtime video. And if I really wanted to kind of feel better about this, and I can, you know, so I think what I'm doing right now is very positive. I'm making this video. This is the 9th video in the FRR. So let's continue with that. We're going to set up an LSP that has that FRR capability, fast reroute capability, and then we'll see it switch over, and that will be that. So maybe I can use the configuration example here to do that, but if I can't, I'll just figure it out on my own. Okay, so this is going to be a really important one. This LBPF, that stands for load balance per packet. That's something I'm just going to need to memorize, and I'm going to make sure that I include that in my configurations. I can tell if they're missing. That's something that's going to be essential. So let's take a look at what's on here right now. So I'll do a show MPLS LSP. There we go. So I've already got a LSP that is up. Let's take a look at the ERO, or actually the RRO would be better to look at, because then we would see the whole path. Okay, so the RRO, and we've got an ingress and an egress. We'll just worry about the ingress for now. Yep, so it's just got two entries in the record routes object. So clearly from the topology, that means that it's going to go here. Let's set up a FRR, fast reroute configuration, so that it can go here if I shut this link down. Because right now, if I were to shut that link down, all that would happen is that these show MPLS LSP, it would go down. So let's try that. Okay, so every 2 seconds I'm going to look at, and let's narrow it down to the ingress. Okay, and every 1 second I think is better. So yep, we're going to see this state switch over to down if I were to shut down GE000 on router 4. Okay, so now what will happen is it will just go to state down. So it's probably got like a hold time, all that sort of thing. So even though the link's down, it can still say that it's up because it's got to go through the process to bring it down. It doesn't go down automatically. Okay, it seems to be taking quite a bit of time though. I think it has to do with the LSP. I believe, I forget what it's called, but I will show what I'm talking about. The CSPF recomputation, I believe. But we can see that LSP is still very much up. Let's take a look at the RRO again. And there's two ways to look at the RRO. There's through the RSVP session details, or there's through the MPLS LSP details. So here's the RRO as shown through the MPLS LSP details, but I prefer the one here because it shows you the total number of entries in there, even though one of the entries is just itself. And from that we can see something really interesting happen that I was actually not thinking would happen. When I shut down this link, it looks like that behavior that I wanted to somehow get to happen by the end of this video was already happening by default. The LSP remained up because it just took a new path. So now we can see there's 3 entries in this, so very clearly it's going this way. If I were to bring that port back up, roll back that change, we'll see this information change. So let's do that. So I'll just keep track of the old information just to be sure, and then I will roll back. Okay, and then we'll take a look at the new information. This is not quite ready yet. Let's do a pipe match, record, route. Pipe refresh to. Okay, so it looks like it did change. Oh no, it didn't change, because we've got the ingress and the egress showing up right now. So the top one is the ingress, the bottom one is the egress. Okay, so that's interesting. It looks like it's not changing back. I wonder if I clear out the information. Let's try that. Clear MPLS LSP all. Okay, yep, so now that I cleared out that information, we can see it changed so that it's only got one. It went back to the other path. Okay, so let's look at the configuration that's on here. So, yeah, and you can see I don't have any special fast reroutes, anything like that set up. Yeah. Here's a good old Wikipedia article. I tend to like, yeah, I'm a fan of Wikipedia as a resource, even though it really can't be a primary resource, but oftentimes they'll have citations at the bottom that are, yeah, like here they're linking to the actual RFC. Yeah. Okay, but FastReroute is a MPLS, multi-protocol switching, and IP resiliency technology to provide fast traffic recovery upon link or router failures for mission-critical services. Upon any single link or node failures, it could be able to recover impacted traffic flows in the level of 50 milliseconds. Industrial implementations can be seen in vendors such as Cisco, Juniper, Brocade, Alcatel-Lucent, etc. I've never heard of Brocade before. In the IP domain loop-free, it's a class of richly decorative shuttle-woven fabrics. In the IP domain loop-free alternatives, LFAs, and not via technology have been used to immediately recover data packet upon the failure of a default next hop. Backup path can be configured for link protection, node protection. There are two methods to backup an LSP, one-to-one. This method creates detour LSPs for each protected LSP at each potential point of local repair facility. This method creates a bypass tunnel to protect a potential failure point. Okay, so oops, it looks like this is a pretty big RFC. Yeah, this is a pretty giant RFC, but I think this is going to be my best bet. I've got about a half an hour left in this video, so oops, but it looks like there's another. It looks like there's another one, so let's see if this has been, so this has been updated by some more ones. Okay, I guess I'm not sure if I want to read fast reroute extensions to RSVP TE for LSP tunnels or IP fast reroute framework. Okay, so I think it's pretty clear that this is high availability techniques for MPLS. So it's clear that it's not going to be for IP because MPLS is about using labels instead of those IP addresses. So it's definitely not going to be this one here. So I'm going to pause it, take a quick break, and when I come back, the whole rest of the hour will be devoted just to reading this RFC. We'll see how far I get, and then I will mark this complete and move on to a next topic in the next video, which will be node and link protection. So I'm going to pause it. I'll be back shortly. Alright, welcome back. I've got the recording ticking and I've got the red circle. I've made that mistake before. So I'm going to update the documentation here for the 9th one. It's just going to be this RFC. I'd love to do this. I'm kind of kicking myself hard for not being able to do this. And you know what? I could be able to if I just deleted all these and recreated them, but I want to cap this. 10 videos is just way too many, so I'm going to be reading this and then moving on to the next topic. This document defines RSVP-TE extensions to establish backup label switch path LSP tunnels for local repair of LSP tunnels. These mechanisms enable the redirection of traffic onto backup LSP tunnels in 10 seconds of milliseconds. In the event of a failure, two methods are defined here. The one-to-one backup method creates detour LSPs for each protected LSP at each potential point of local repair. The facility backup method creates a bypass tunnel to protect a potential failure point. By taking advantage of MPLS label stacking, this bypass tunnel can protect a set of LSPs that have similar backup constraints. Both methods can be used to protect links and nodes during network failure. The described behavior and extensions to RSVP allow nodes to implement either method or both and to interoperate in a mixed network. Introduction. This document extends RSVP to establish backup label switched path LSP tunnels for the local repair of LSP tunnels. This extension will meet the needs of real-time applications such as voice over IP, for which user traffic should be redirected onto backup LSP tunnels in 10 seconds of milliseconds. This timing requirement can be satisfied by computing and signaling backup LSP tunnels in advance of failure and by redirecting traffic as close to the failure point as possible. In this way, the time for redirection includes no path computation and no signaling delays, including delays to propagate failure notification between label switched routers, LSRs. Speed of repair is the primary advantage of the methods and extensions described here. The term local repair is used when referring to techniques that redirect traffic to a backup LSP tunnel in response to a local failure. A protected LSP is an explicitly routed LSP that is provided with protection. The repair methods described here are applicable only to explicitly routed LSPs. Application of these methods to LSPs that dynamically change their routes, such as LSPs used in unicast IGP routing, is beyond the scope of this document. Section 2 covers new terminology used in this document. Section 3 describes two basic methods for creating backup LSPs. Section 4 describes the RSVP protocol extensions to support local protection. Section 5 presents the behavior of an LSR that seeks to request local protection for an LSP. The behavior of a potential point of local repair, PLR, is given in Section 7, which describes how to determine the appropriate strategy for protecting an LSP and how to implement each of the strategies. Section 7 describes the behavior of a merge node, the LSR where a protected LSP and its backup LSP rejoin. Finally, Section 8 discusses the required behavior of other nodes in the network. The methods discussed in this document depend on three assumptions. The first assumption is that an LSR is on the path of a protected LSP should always assume that it is a merge point. So an LSR that is on the path of a protected LSP should always assume that it is a merge point. This is necessary because the facility breakup method does not signal backups through a bypass tunnel before failure. The second assumption is if the one-on-one backup method is used and a detour object is included, the LSRs in the traffic engineered network should support the detour object. This is necessary so that the path message containing the detour object is not rejected. The final assumption is understanding the detour object is required to support the path-specific method, which requires the LSRs in the traffic engineered network be capable of merging detours. Background. Several years before work began on this document, operational networks had deployed two independent methods of doing FastReroute. These methods are called here one-to-one backup and facility backup. Vendors trying to support both methods experienced compatibility problems in attempting to produce a single implementation capable of interoperating with both methods. There are technical trade-offs between the methods. These trade-offs are so topologically dependent that the community has not converged on a single approach. This document rationalizes the RSVP signaling for both methods so that any implementation can recognize all FastReroute requests and clearly respond. The response may be positive if the method can be performed, or it may be a clear error to inform the requester to seek alternate backup means. This document also allows a single implementation to support both methods, thereby providing a range of capabilities. The described behavior and extensions to RSVP allow LERs and LSRs to implement either method or both. While the two methods could in principle be used in a single network, it is expected that operators will continue to deploy either one or the other. The goal of this document is to standardize the RSVP signaling so that a network composed of LSRs that implement both methods, or a network composed of some LSRs that implement one method and others that support both, can properly signal among those LSRs to achieve fast restoration. Okay, so the reader is assumed to be familiar with the terminology in these two RFCs. The first term is LSR, which stands for Label Switch Router. LSP, an MPLS Label Switch Router. Sorry, an MPLS Label Switch Path. In this document, an LSP will always be explicitly routed. Local repair. Techniques used to repair LSP tunnels quickly when a node or link along the LSP's path fails. PLR, point of local repair, the head-end LSR of a backup tunnel or a detour tunnel. One-to-one backup, a local repair method in which a backup LSP is separately created for each protected LSP at a PLR. Facility backup, a local repair method in which a bypass tunnel is used to protect one or more protected LSPs that traverse the PLR, the resource being protected, and the merge point in that order. Protected LSP, an LSP is said to be protected at a given hop if it has one or multiple associated backup tunnels originating at that hop. Detour LSP, the LSP that is used to reroute traffic around a failure in one-to-one backup. Bypass tunnel, an LSP that is used to protect a set of LSPs passing over a common facility. Backup tunnel, the LSP that is used to back up one of the many LSPs in many-to-one backup. N-hop bypass tunnel, next hop bypass tunnel, a backup tunnel that bypasses a single link of the protected LSP. NN-HOP bypass tunnel, next hop bypass tunnel, a bypass tunnel that bypasses a single node of the protected LSP. Backup path, the LSP that is responsible for backing up one protected LSP. A backup path refers to either a detour LSP or a backup tunnel. MP, merge point, the LSR where one or more backup tunnels rejoin the path of the protected LSP downstream of the potential failure. The same LSR may be both an MP and a PLR simultaneously. DMP, detour merge point. In the case of one-to-one backup, this is an LSR where multiple detours converge. Only one detour is signaled beyond that LSR. Reroutable LSP, any LSP for which the head-end LSR requests local protection. See section 5 for more detail. CSPF, constraint-based shortest path first. SRLG Disjoint, a path is considered to be SRLG Disjoint from a given link or node if the path does not use any links or nodes which belong to the same SRLG, which stands for Shared Risk Link Group, as the given link or node. Local repair techniques. Two different methods for local protection are described. In the one-to-one backup method, a PLR computes a separate backup LSP called a detour LSP for each LSP that the PLR protects. In the facility backup method, the PLR creates a single bypass tunnel that can be used to protect multiple LSPs. One-to-one backup. In the one-to-one backup method, a label switched path is established that intersects the original LSP somewhere downstream of the point of link or node failure. A separate backup LSP is established for each LSP that is backed up. In the simple topology shown in example 1, the protected LSP runs from R1 to R5. R2 can provide user traffic protection by creating a partial backup LSP that merges with the protected LSP at R4. We refer to a partial one-to-one backup LSP, R2, R7, R8, R4, as a detour to protect an LSP that traverses n nodes fully. There could be as many as n-1 detours. Example 1 shows the paths for the detours necessary to protect fully the LSP in the example. To minimize the number of LSPs in the network, it is desirable to merge a detour back to its protected LSP when feasible. When a detour LSP intersects its protected LSP at an LSR with the same outgoing interface, it will be merged. When a failure occurs along the protected LSP, the PLR redirects traffic onto the local detour. For instance, if the link R2, R3 fails in example 1, R2 will switch traffic received from R1 onto the protected LSP along link R2, R7 using the label received when R2 created the detour. When R4 receives traffic with the label provided for R2's detour, R4 will switch that traffic onto link R4, R5 using the label received from R5 for the protected LSP. At no point does the depth of the label stack increase as a result of the detour. While R2 is using its detour, traffic will take the path R1, R2, R7, R8, R4, R5. Facility backup. The facility backup method takes advantage of the MPLS label stack. Instead of creating a separate LSP for every backed up LSP, a single LSP is created that serves to back up a set of LSPs. We call such an LSP tunnel a bypass tunnel. The bypass tunnel must intersect the path of the original LSPs somewhere downstream of the PLR. Naturally, this constrains the set of LSPs being backed up via the bypass tunnel to those that pass through some common downstream node. All LSPs that pass through the point of local repair and through this common node that do not also use the facilities involved in the bypass tunnel are candidates for this set of LSPs. In example 2, R2 has built a bypass tunnel that protects against the failure of link R2, R3, and node R3. The doubled lines represent this tunnel. This technique provides a scalability improvement in that the same bypass tunnel can also be used to protect LSPs from any of R1, R2, or R8 to any of R4, R5, or R9. Example 2 describes 3 different protected LSPs that are using the same bypass tunnel for protection. As with the one-to-one method, there could be as many as n-1 bypass tunnels to fully protect an LSP that traverses n nodes. However, each of those bypass tunnels could protect a set of LSPs. When a failure occurs along a protected LSP, the PLR redirects traffic onto the appropriate bypass tunnel. For instance, if link R2 through R3 fails in example 2, R2 will switch traffic received from R1 on the protected LSP onto link R2 through R6. The label will be switched for one which will be understood by R4 to indicate the protected LSP, and the bypass tunnel's label will then be pushed onto the label stack of the redirected packets. If penultimate hop popping is used, the merge point indicated in example 2, R4, will receive the redirected packet with a label indicating the protected LSP that the packet is to follow. If penultimate hop popping is not used, R4 will pop the bypass tunnel's label and examine the label underneath to determine the protected LSP that the packet is to follow. When R2 is using the bypass tunnel for protected LSP1, the traffic takes the path R1, R2, R6, R7, R4, R5. The bypass tunnel is the connection between R2 and R4. RSVP extensions. This specification defines 2 additional objects, FastReroute and Detour, to extend RSVP-TE for FastReroute signaling. These new objects are backward compatible with LSRs that do not recognize them. Both objects can only be carried in RSVP path messages. The session attribute and route record objects are also extended to support bandwidth and node protection features. FastReroute object. So we do know this route record object should be very familiar. We just looked at that earlier. The FastReroute object is used to control the backup used for the protected LSP. This specifies the setup and hold priorities, session attribute filters, and bandwidth to be used for protection. It also allows a specific local protection method to be requested. This object must only be inserted into the path message by the head-end LER and must not be changed by downstream LSRs. The FastReroute object has the following formats. Setup priority. The priority of the backup path with respect to taking resources in the range 0 to 7. The value 0 is the highest priority. Setup priority is used in deciding whether this session can preempt another session. See RSVP-TE for the usage on priority. Holding priority, the priority of the backup path with respect to holding resources in the range 0 to 7. The value 0 is the highest priority. Holding priority is used in deciding whether this session can be preempted by another session. See RSVP-TE for the usage on priority. Hop limit, the maximum number of extra hops the backup path is allowed to take from current node, a PLR to an MP, with PLR and MP excluded from the count. For example, hop limit of 0 means that only direct links between PLR and MP can be considered. Flags 0x01, one-to-one backup desired, requests protection via the one-to-one backup method. 0x02, facility backup required, requests protection via the facility backup method. Bandwidth estimate, 32-bit IEEE floating point integer in bytes per second. Exclude any, a 32-bit vector representing a set of attribute filters associated with a backup path, any of which renders a link unacceptable. Exclude any, a 32-bit vector representing a set of attribute filters associated with a backup path, any of which renders a link acceptable with respect to this task. A null set, all bits set to 0, automatically passes. Include -all, a 32-bit vector representing a set of attribute filters associated with a backup path, all of which must be present for a link to be acceptable with respect to this test. A null set, all bits set to 0, automatically passes. The two higher order bits of the class num11 cause nodes that do not understand the object to ignore it and pass it forward unchanged. For informational purposes, a different C-type value and format for the FastReroute object are specified below. This is used by legacy implementations. The meaning of the fields is the same as that described for C-type 1. Unknown C-types should be treated as specified in RSVP section 3.10. Okay, so didn't even get through, probably got through about a fourth of everything, but unfortunately that's as far as I can get. I just don't have a ton of time. I picked up my test date. It is going to be more than a month away, but it's going to be less than 2 months away, so time can really catch up. And I spent over a week on this one topic alone, and I've got way more than 4 topics left. So if it's a week for topic, I'm not even going to finish the very next section here. Oh, well, let's see here. So if it's a week per topic, I would finish these 3, and then I would just start to be touching on VPNs. So I definitely need to be moving a lot faster. So I'm definitely going to mark FastReroute as being done. So thanks for watching, and stay tuned for the next video where I go over node and link protection.